Who I had for my March project was Emilie du Chatelet. She was a French physicist and mathematician. She was born in 1706 and died in 1749. She is most famous, though, not for her work in the maths or physics field, but for being Voltaire's mistress, even though she was so much more important than that. Her parents were Louis Nicolas Le Tonnelier de Bruxelles and Gabrielle Anna de Frolet. And at this time, it wasn't socially acceptable for women to be in the maths field or just STEM in general. And so her mother did not approve of her being curious necessarily for the sciences. However, her father encouraged her greatly, and they had a lot of money, so she was able to learn at home with books in her own laboratory. So again, as I said, she was educated at home and she picked up gambling. She was especially successful at gambling because she was mathematically inclined, and she used the money that she won to buy books and laboratory material. At 18, she married Marquis Florent Claude du Chatelet. However, he traveled a lot and wasn't around a lot. This gave her advantage, A, where she fell in love with Voltaire and became his mistress, and B, she was able to do all the experiments and write all her books with all the time she's had on her own. So some of the books that she has written is Philosophy Naturalis Principia Medica, Dissertation sur la nature et la propagation des feux, Elements of Newton's Ideas. This one she wrote with Voltaire, and although they both wrote it together, only Voltaire is on the book. She also wrote Foundation of Physics. Foundation of Physics is important also because she tried to integrate like the similarities and differences between Newtonian, Cartesian, and Leibnizian views. So most of why she's like super important in mathematics is because she translated Newton's principles or Principia. So Newton's ideas were not accepted at this time in France. It was all in Cartesian, and she kind of got a little backlash because she was doing Newton's ideas. But it was so important that she translated because she didn't just translate it, but she added her notes. She added more examples, derivations, and clarifications. A lot of Newton's notes were very obscure and hard to follow, and she not only simplified it down but added more to it. She also did additional experiments proving theorems, and she wrote it in a modern notation. This allowed France and just like French scientists to move forward and to understand Newton's law and kind of transform from Cartesian to Newtonian. She ended up having 3 children, but at age 42, she became pregnant, and she knew that most women do not survive pregnancy or giving birth at that age. And so she worked double time to finish her book. She ended up having the child, and then 6 days later she died. She is a really important figure that is often overlooked because of her gender and the time and her career at that time. So some of the mathematical importance she had. Her husband traveled a lot, as I mentioned before, and gave her a lot of time and space to perform the experiments. Her experiments were especially important in energy and energy conservation. So she performed an experiment also performed by William S. Gravelisande. This was, but she used lead balls to drop into clay. This showed that the balls that hit the clay with twice the velocity penetrated 4 times as deep into the clay, and balls that hit with 3 times the velocity were 9 times as deep. From this, she showed that energy is proportional to mass times velocity squared, or E equals mv or c squared. So kind of this written out would be the mass she was using was lead balls and they were constant. So mass in all these situations is constant and the same. However, she changed the velocity, and when the velocity was 1, the energy was 1. And energy is how far the ball goes into the clay. But when she changed the velocity to 2, she noticed that the ball went 4 times deeper into the clay, so energy was 4. And again, she tried again with 3, the velocity being 3 times, and the energy or the clay, the ball went into the clay 9 times as deep. So from this, she figured that energy equals mass times velocity squared. And here are my citations.